Okay, guys. So this is the last unit, unit 12, area and volume, and we are talking here about areas, what's areas and volumes, and I call this first part of the unit basic solids. Okay, this is not a really accurate term. Okay, but I thought it was a good way to group those first solids that we are going to cover here. Anyway, I'm going to describe now which solids I'm referring to. Okay, as you might guess, solids or geometric bodies are um, 3D shapes. Okay, 3D shapes. So the ones I called basic solids are actually the following. You know, there are two big groups of objects in geometry, of 3D objects, and those are polyhedra, polyhedros, and round bodies, cuerpos redondos. Okay, so the ones I call basic solids are regular polyhedra. Okay, I will go a little bit more into this in a minute. Regular polyhedra, right prisms, right pyramids, and then in the round bodies, spheres, cylinders, and cones. Okay, so what is regular polyhedra? Regular polyhedra are those polyhedrons that in which all the sides or all the faces are congruent polygons. Okay, all of them are congruent polygons. And these five are like the most common ones. First one is the tetrahedron. Okay, you know these names are in Spanish, but actually in English it's very, very similar. So tetrahedro in English it's actually tetrahedron. Okay, icosahedro in English is icosahedron. So it's quite similar. So tetrahedron, that's a polyhedron where all the four faces are equilateral triangles. Hexahedron, six faces, each one of them are squares. Okay. This is the octahedron. Those are eight equilateral triangles. Dodecahedron, that's 12 faces, which are polygons. And then we have the icosahedron, which are 20 faces that are equilateral triangles. Okay, those are the most common regular polyhedron. And then we have prisms. You know, prisms are also a very common shape. Okay, but I cannot call this a regular polyhedron because not all the faces are congruent. Okay, that's why I cannot call it a regular polyhedron. And but for me, it's also a basic solid, let's say. So as you know, a prism is just an object where there are two bases which are congruent polygons. Okay, so this base and the base below, they are two congruent polygons. So as you know, this can be like this, a triangular prism where the bases are triangles. It can be a quadrangular prism, pentagonal prism, and so on. Like I can use any polygon for the basis and it's a prism. Perfect. Okay, that one is easy. I have the pyramid, okay, which is also one of the basic objects for me. If the pyramid has three sides in its base, it is actually a regular polyhedron. Okay, I already described that one, which is the tetrahedron. But as soon as I have more than three sides there, it's not a regular polyhedron, but it's a pyramid and it can have any amount of sides in the base. We usually work with triangular pyramids, uh, square pyramids, pentagonal pyramids, anything, okay? but those are the most typical ones. So right prisms, so prisms that are standing like that, growing right like that, pyramids, right pyramids like this one, which are like standing perfectly. And we have as well some round bodies, which are pretty common, and those are spheres, okay, cylinders, cylinders and cones. Okay, those are the two types of round bodies that I consider as basic solids. And in this part, we will be what we will be doing basically is finding volumes and surface areas. Okay, for volumes, usually you have a formula. For surface areas, it depends. Like for instance, for round bodies, usually you have a formula for surface areas. But just to review the concept, let's take this prism. Let's make it a square prism. I turn that. So if I make this 10, 10, and 20, finding the volume is really easy, right? It will be 10 times 10, that would be 100 square units. That would be the area of the base, times 20 units, which is the height, okay? So that would give me 2,000 cubic units. That's the volume, okay? Very easy. And if I want to find the surface area, what I need to do is find the area of each one of these four sides, add them, the area of the base, multiply it by 2, and then we add all together. And that's the surface area of a prism. It's the same logic with all the shapes. For some of them, you will have to look for the formula. For some of them, you can guess it, but that's the concept. So that's what we are going to do today. We are going to review this, and you're going to review that working on IXL. So I'm going to just stop recording here